I welcome you to the Pistoy Alliance webinar on the Federated Knowledge Graphs for Scalable Data and AI in Pharmaceutical Research. And meanwhile, I would like to introduce our esteemed speakers today and passing the microphone to Maxim, please.
So my name is Maxim Kulchin. I'm a product owner at Boehringer Ingelheim. So I'm going to talk today about the idea of the knowledge foundation and how we implementing it in Boehringer.
And Peter, please.
Yeah, Peter, I'm running the pre-sales team at Metafacts, the company that has provided some of the underlying technologies for projects that we will see today.
Thank you. Before we begin the talk, there is a poll that I would like to share with the audience. There are 5 questions in this poll. They will be presented to you in this screen that you see that has just popped up. Please answer the questions. It's a multiple choice, yes, no, or not sure. There is only one answer possible for each question. We will be monitoring the poll from here, and to keep the experiment clean, I personally am abstaining from voting. And once we see that the majority of the audience had a chance to vote, we will share the results with you. At this point in time, we have about 100 votes, and the votes are still coming in, so let's keep the poll up for a few more moments. And the flow of answers is slowing down. So maybe a few more moments and then we will be ending. So if you want to vote, please don't delay. Do it right away as soon as you can. And with 122 votes total, here are the results. Have you ever worked directly with knowledge graphs or ontologies? The overwhelming is yes. 75% say yes, 22% say no. Before this webinar, were you familiar with the term knowledge graph federation? About half of our respondents say yes, about 35% say no, and there are some people who are not sure. So they might have seen the term but do not know how it fits in the overall production pipeline. Do you believe traditional data management approaches are scalable to effectively source data for AI? Answer is no. And the second popular is not sure, and I would interpret it as no as well, because if you're not sure how to find the data, you probably don't have the data, and so it becomes a barrier to productionizing AI. Number 4, do you believe AI systems should be able to access and use data autonomously, that is, without human intervention, to reach their full potential? This is a really interesting question. I'm happy to see it in our event. The distribution of answers here is almost flat. About an equal number think yes and no, and a slightly smaller number of respondents say not sure. And does your organization have a governance framework that could support federated data management? Here also we have an almost flat distribution of answers, about a third of each answers. yes, no, and not sure. So I think that was quite interesting and instructive. In particular, I like the autonomous data access question, to tell you the truth. And I find it quite valuable to see. I will stop sharing the poll results at this point. I see that some people are raising hands. I encourage you to please type your questions in a question and answer feature in the Zoom webinar. We will take questions at the end of the event for greater efficiency in conducting the speeches. So thank you for understanding. At this point, I will stop sharing my screen and I'll pass the controls to Maxim. Maxim, please go ahead.
Now, yes. Thanks, Vladimir. Okay, I'm taking the control. Good. So, okay. So again, welcome everyone. Thanks for joining. So I guess you saw the title and you know what I'm going to talk about. So let's get started. So about a little bit about me. So I'm in my work. So I joined Boehringer and started working with knowledge graphs around 6 years ago. And for the last 3 years, I have this more kind of formal role of a product owner, where I'm together with a small team of software engineers and knowledge engineers, building and operating in so-called enterprise knowledge graph platform, how we call it internally. So you see my organization a little bit on the slide. So the platform itself is part of a larger data ecosystem, which we call data land. And the data land is quite cool thing because it changed a bit. I mean, changed quite a lot the way how we manage data in Boehringer, because it defined clear ownership of the data and set up federated data governance, where every business area is responsible for their own data to manage and distribute. I'm part of a bigger IT organization, which in general builds software development and data platforms for the global corporation. And yeah, it's Boehringer. I guess you heard about it, right? So what I want to talk about today is that, yeah, it seems like the main problem with the data today is not amount anymore, right? And pretty clear, so we can work with lots of data easily. The problem is really the diversity and complexity, right? So how to get data from multiple sources and insights from it. So I believe, I mean, you know pretty well the challenges in your company, you know, concrete challenges in every area of the industry and so on. So I'm not going to tell anything new here, but what I want to, how I want to start the talk is I want to generalize the challenges quite a bit. Maybe it's a bit too simplistic, but I think it will help the story, right? And then I want to tell what is the dream there, how it could look like in the future, hopefully, right? So today's challenges I would summarize like this, and the challenge is threefold. So we're having a growing demand for use cases where we need integration from many diverse sources. So it's not anymore just one department, one business unit working with their own data. We need data from other business units, other departments. We need external data to get insights, right? And the demand, but the cost of integration is quite high. And here, what I try to visualize is that what I see in general is that with the growing number of use cases demanding data integration, the cost is going super up, right? Grows rapidly. And third thing is that with the new era of AI, with large language models and so on, the user experience expectations of people went, changed quite a lot. Now people expect fast and easy access to data, because now people can see and really already got used to the fact that you can formulate your question, just write it, and then get really complete and sensible answers, right? It may be hallucinations and stuff, but you get fast replies, right? And from different places. So what these challenges, what is the problem with these challenges is that I see that at some point for some use cases, they reach, I would call a breaking point, when the effort to get enough data from different places is that high that they don't do it. So I don't know, they skip a decision, or they take a risk. Or I even heard that sometimes people say, hey, it's cheaper to repeat an experiment than to go back and try to find data of the experiment which was done 5-10 years ago. It's hard to find, okay, but once you find, you still need to make sense of that. You need to merge it with the data we have today, right? So at the end, at some point it may become too expensive, too much time to execute, and the return on investment is not clear, right? And the dream would be that, hey, it should be really cheap to integrate new data, not like today. And it should be really low effort for use cases to access diverse data sources, so that we minimize chances of reaching this breaking point, right? So that we could have more use cases running in parallel without generating duplicated effort, duplicated data, and getting the insights which we couldn't get today. So how we get to that? What actually stops us from doing this? Which things stop us from scaling? And in general, I would say this is manual work. So manual work stops us from scaling data management to the levels which people expect today, to the levels to the level where we would data management would meet capabilities of AI, right? So with AI, you get fast access to the data, but not your private data of your company, data which AI was trained on. And of course, to get benefits, you want private data to be there as well. And what I think stops us, as I mentioned, it's manual work. And manual work, I see, comes mainly from 3 places. And the first place is data pipelines. Quite a lot of pipelines, which I'm not talking about like Boehringer specifically, but in general, from my experience in general, a lot of pipelines built for a particular use case, and the output is not reused. So we should stop building pipelines if output is not universally reusable. You should not have a pipeline which generates output, and then for someone to use the output, they need to create yet another pipeline to transform it, to integrate it with data they need. Second thing is data identifiers. Again, manual work is spent on data engineers, data stewards, trying to figure out how to match data came from one source and data came from another source. And then we develop different tools to ease the job, to make it business friendly, so that not IT spends time on the matching, but business spends time on the matching. but still the company as a whole would have to spend time on the matching, right? So manual work again. So we need to have identifiers which are usable, and if they are not planned to be reusable, we should try to avoid creating them, hopefully. Right? And the third point is closed vendor-specific data environments. Again, you buy a solution, and right away you need to start a project to implement pipelines or matching mechanisms to move data into this solution. Again, manual work doesn't help. And I like this picture very much, so so I'm reusing it here. So these are the three things which I think really stops us from scaling. Today's AI is amazing, does quite a lot of useful things, and we have a lot of projects in Boehringer which generated quite a lot of value. People are happy using these projects, or all good. But I don't think really that AI will solve the problem with data management we have, right? Again, if we generalize, and we're not talking about local use cases, right? So you can bring data just for your use case, or 2 or 3 relevant use cases. Spend time on integrating it, massaging, transforming it, right? Loading it to database or something like that. But globally, the problem is not going to be solved. To solve the global problem, what you have two options today, as far as I see. You could turn all your data into text and load into vector database. So you take your data from data warehouses, data from data lakes, from other places. Okay, documents are easy, they're already in the text, but the structured data, so you would need to turn that into the text then. I don't think it makes sense. Second thing, yeah, now we have protocols to give LLMs access to our private data, right? And one of them, model context protocol. So nothing wrong with the protocol itself. So I think it's a really good thing to have. But again, if we think about giving access to the LLM to all the data we have in the company, can we do that via MCP? If we do it the same way how we build APIs to the source systems, it means we need to create quite a lot of MCP servers. Can we scale that? It seems like quite a lot of manual work. And if you already had experience in your company going through enabling this API access to the source system data, you already know, and you can already estimate how much effort needed to build such an API. So with MCP, that would be a repetition of the work from my point of view, right? So let's recap the problem. So the challenge is data integration, which is caused by manual work, which requires manual work. It's, manual work didn't cause it, but yeah, data integration today requires quite a lot of manual work. Worse if you have a GXP system and you need to document that even. So we need really scalable solution. So I want to talk a bit about this, like the high-level vision for Knowledge Foundation, and which I have, and I will talk what we're doing in Boehringer later. So how these kind of problems solved traditionally. So we have a problem of high complexity, and when you have a problem of high complexity, you usually, at least in computer science and software engineering, you introduce an abstraction. There are tons of examples when we did it. So you can take high-level programming languages. So nowadays you don't think how code is executed by CPU and GPU and so on. You just write the instructions in high-level language. We have network protocols, TCP/IP, application layer, MCTP for emails, sending emails, right? So we're not thinking about how to deliver packages over network. there is an abstraction on top of that. So it seems like we need an abstraction. So instead of doing incremental updates, incremental improvements in different places of our data landscape or data ecosystem or whatever, we need to do something else. And we need to introduce an interface which would provide simplicity for data consumers and would give simplicity for data providers, right? So if we look at it from the perspective of a data consumer, and here I have 4 examples, right? Like typical examples. We have today AI agent, we have a business intelligence dashboard, some web application or desktop application, and machine learning pipeline. So all of them they normally or usually use different protocols to access the data, right? So we have MCP, GBC, GraphQL. Okay, data frame is not really a protocol, but you can do something on that. You can extend it to make it accessing the data directly, right? So abstraction layer would be sitting on top of all this messy data, hiding the complexity, and enabling flexibility for these applications. So meaning the consumer would not think where the data is located or how structured, what is the format, how it needs to be merged, and so on. So they would have a layer. Imagine for the let's say if we're talking about dashboard would have access to the big data warehouse with tons of tables available from all the company. Of course, not all the data, you need to control the access and so on, but to all the tables and relations there for querying, right? And if we take a bit do an imaginary exercise and think, hey, what would be the customer feedback of these 4 actors to this knowledge foundation layer? The AI agent, I think, would say, hey, that's good. Now I can see, I know what data is available for me, so I can myself access a catalog. I don't need to wait for my human to tell me what data is available or do something for me. I just can go to the catalog. And instead of calling lots of MCP servers and getting a lot of information which can overload my context window, I can ask a specific question in a query language to fetch really specific data I'm interested in, not bothering about where it's located. And if I don't have access to data I need, I can instantly ask my human to request it, right? So that would be, I would expect this kind of feedback from AI agent. And yeah, let's talk about application, right? So today, if we implement web application, again, depending on the size of the application, you need to do quite a lot of requests. And the life of application developer would be much easier if there would be one single window where they could request all the documents they need. And all these documents would be already integrated with each other, right? So, and you would not have to, the application developer would not have to write all this business logic in the application itself, which should be in the data, right? So the barrier would be much easier. Same thing with machine learning pipelines. You know, the famous 80-20 problem with data science couldn't be solved with this abstraction. How do we build this? How we can build it? I think we already have today tools for that. So we have RDF and SPARQL standards, and the knowledge foundation would be kind of a network of domain-owned knowledge graphs. So remember, actually here I assume that we have this federated data governance where every data asset is owned by a particular business unit, right? And there are no, and these governance framework allow us to avoid duplicates. So if someone takes care about clinical data, then there is no other department doing it again, right? But this RDF and SparkQL could allow them to create this network, right? And the network would be created with the global unique identifiers, which we know very well. The problem here is this Sparkle-based query engine, right? So we need something really remarkably smart and scalable to create this simplicity. I mean, of course, it don't have to be one application running all the queries. It could be scaled with load balancer and stuff. But we already have today solutions where you can rewrite SQL queries to SparkQL. You can rewrite GraphQL to SparkQL. You can do the same with MCP, I assume, right? So we can generate the interfaces I mentioned in the previous slides with SparkQL queries on the background. So we in Boehringer, for example, some time ago, we started working with open source software called FedEx. Of course, FedEx is not what I'm talking about here, but this is really a good start. So already a simple version of such an engine helps us to have data browser for exploration of the data across knowledge graphs. Okay. So from the data provider producer perspective, this abstraction could mean that they can multiply productivity, because instead of creating multiple versions of the same data in different systems or thinking about how to distribute it properly, how to create different versions of data products and so on, they could focus on one instance of their data in form of a knowledge graph, and they would have more time for alignment, right, between different data producers, right? And alignment would be needed because they would need to start thinking about things they're usually not thinking about. So the reusable identifiers, how to make sure that the duplicates not introduced into the foundation, and so on. Different providers need different ways of ingesting data, and today already I can imagine we can support these four. So if you have a data warehouse, you can virtualize it. If you have data source which is not cannot be virtualized, you can have a classical ETL pipeline, but it's not the ETL pipeline I was talking at the beginning, right? Because the output is high, will be quite much more reusable here. The CRUD application, CRUD meaning here is create, remove, update, delete, meaning that the people could manually add records to the data, right? Again, if we talk about the customer feedback here, what our customers, the data producers would tell. Yeah, I can imagine that the reference master data domain owner would say, hey, now we have an opportunity to actually don't spend time internally cleaning up data which people already have somewhere. We could go find an external provider and connect it in form of a knowledge graph to our knowledge foundation. No ETL pipelines needed to build and maintain. The compound data domain owner would say, yeah, I need to have, I'm using an application to add compounds regularly, right, manually, and review it with my colleagues. So with knowledge foundation and RDF and SparkQL, it would mean that they have a application with the forms auto-generated from the knowledge graphs, and then as soon as they add data records they need about compounds, they right away available in the knowledge foundation for consumption. So no extra step needed from their side, no integration or pipelines again. Right? The omics data owner would say, yeah, so I'm getting raw sequencing data from multiple laboratories. We have a process to automatically do some calculations on top of them, which we store in data warehouse. but I don't need to spend time on distributing it to the researchers across the organization because data warehouse is virtualized into the knowledge foundation. No pipelines, no waiting time. And why do we talking about knowledge graphs and specifically about RDF-based knowledge graphs? Because I think this is exactly the tool designed for the job, right? So it's vendor agnostic and has a wide community of adopters across the industry. And vendor agnostic doesn't mean that we don't want to work with vendors. It means that vendors can focus on better user experience, smarter features, and not reinventing the wheel. And at the end, customers moving from one data ecosystem to another. And RDF is quite flexible to represent any data we have and natural to think about because it's a graph representation. You don't need to, represent, the concepts and stuff into a representation which is more restrictive. There are flexible and powerful data schema languages which can be used. Yeah, sometimes they are too flexible. With flexibility comes, need for better control and stuff. Sometimes we think it's too complicated, but it actually works, and we can see it working. Data identifiers would enable connectivity across data domains. So from the tabular data, we know about primary and foreign keys. So that's basically the same. It's just they are explicitly defined and globally unique. At the end, this is really well fit into FAIR principles, which I assume you know pretty well, right? So out of the box, data would be fair. Why it cannot be that simple? So why, why not try to think about it, right? And not trying to do local optimizations, but actually think about the global picture, take, I don't know, 2 or 3 steps back and see how we can do things really differently. And so I would say from my experience so far in Boehringer, I can see that we're actually able to do things with less resources and achieving more results than we could otherwise, right? Okay. So that's basically, that's my dream. I don't know. Sometimes people say that dream is something we don't expect to achieve, or sometimes dream is something we know that it's achievable. This is why we dream about it. Okay, so what we're actually doing at Boehringer today. So yeah, of course, we don't have full implementation of what I just talked about. However, I think we're getting closer, and yeah, we're going in the direction. You see some numbers on the slide. This is comparison to the last year and 2025 November. So hopefully the numbers will grow a little bit more. So from the beginning, these numbers, grow steadily over the last 3 years when we started counting, actually. Not everything can be easily calculated, like monthly active users, for example. That's a bottom line because there are quite a lot of users using service, going to the APIs via service accounts. So for us, they are kind of anonymous. So what we focus on today, 3 things: self-service and self-learning user experience, right? So majority of people, as you know, have no clue about knowledge graphs, ontologies, and stuff. So a lot of upskilling education is needed, an explanation, what is this? And self-service. So people really like when they can do things themselves. No one likes to open support tickets and wait. Control vocabularies as a low hanging fruit for, I guess, in all pharma companies. So that's where we're looking at to introduce more automation, reduction of duplicated effort, and so on. And so this approach and technology is really well fit for that. Hypercare support for high-level use cases. Yeah, so the the goal is quite far away, and you need to source it with success stories, right? And you can get that from high value use cases. And we have some. So who are our customers today? And here I just mentioned several user stories. Some of them already were publicly. Well, my colleagues from Boehringer talked about them publicly in the last 3 years. I mean, the biggest one so far we had is the omics data management, where they help to our therapeutical areas researchers to get spend shorter time to insight. So they reduced it 3 times. Quite a lot of savings thanks to the automation, savings on infrastructure, savings on consulting, external consulting costs, and so on. Supply chain side, and that's quite an interesting use case because here people created quite a lot of knowledge graph, sourcing data from different places across the company to reduce time to answer, because usually supply chain managers in Boehringer, or I guess in general as well, spend quite a lot of time searching for the data across IT systems. So now they can go to a single place and get the answers quicker. And actually, some time ago in Pistoia Alliance, there was a talk from our colleagues in regulatory affairs where they talked about a solution, how they now able to align our internal drug product data with EMA product database. And our internal data comes from the knowledge graphs. And the tool they are using is allowing to do quite generalized comparison. So it's not a tool designed specifically for comparing drug product data, but you can use it for other kinds of data as soon as it's in the knowledge graph. So so that's the story. So I'm happy to answer your questions. What do you think about this topic? What is your situation? What is the situation in your company? Would be interesting as well. If you cannot share in the Q&A, then feel free to contact me by email. We're happy to chat. Thank you very much.
And now maybe a quick word by Peter. Peter, would you like to add something?
So I think what from Metafac's perspective we can see is that this is a general trend in the industry, that this kind of harmonization of data using RDF graphs, especially in the context together with AI, is getting more traction, and so we really appreciate it to have Maxim here today, and thanks a lot for your presentation. But I think for the main discussion, the audience would be more the main contributors. I have prepared a couple of slides talking a little bit about the technologies that are under the hood of such a solution that we can follow up. But Vladimir, over to you when you say it's the right point in time of this presentation that I should show them.
I think right now is quite good. I think we can afford, 5 or 6 minutes for a couple of additional slides and then transition to questions.
Okay, great. Then I will share my screen. So I think you can see me now on my screen. Metafacts is my company. As you can see from this slide, we are a knowledge graph focused company. We develop mainly two software solutions, Metafactory and its AI extension, Metis. Both have the intention to simplify life of people who want to work with RDF graphs and ontologies. Solutions that are built on our platform are typically coming along with components like the ones that I have shown here. And this is, if you want an end-to-end semantic layer that we describe here with this metaphactory platform. It starts on the left side with data sources, your data, and data access through the semantic layer. Here we have the capabilities that bring us federation. Two different methodologies are supported. I will talk about this on the next slide a little bit deeper. But then we have also like schema to ontology and data ingestion, which then require all these complex ETL processes. But in real projects, it's always a mix of federated access and data ingestion to connect or bring the data into the knowledge graph database that sits in the middle in the semantic layer core, where you then have also the ontology and the visual and AI supported modeling capabilities and also the governance processes to manage this. This is in the middle. And once you have then the data connected and integrated into your graph and into your semantic layer, you would like to work with it. And here, interfaces supported by our solution, that these are the typical ones that you have in such semantic layer solutions. Talk to your graph, MCP, APIs, and also, in our case, no-code and low-code dashboard development. That's a capability also provided by our platform. Only half a year ago, this was the first point at my list. Yeah, you can see that in the meantime, everybody starts when talking about knowledge graphs and the need to get it implemented. It's AI is a big driver. But here we are talking mainly about federation today, so I would explain a little bit more about these two technologies. Both technologies are here. You find links explained in detail in scientific publications, and also on help.metafacts.com. You find experts will find a lot of background information. FedX, in the meantime, it's an open source RDF4J framework. Our company and members of our team have contributed a lot to this invention. It's a transparent Sparkle federation. That means the Sparkle programmer does not have to take care on where and which data source, data graph, the original information sit. It's transparent. But this FedX has, in addition, performance optimization possibilities, because you can, let's say, optimize the routing in this federation process through the ontology. Ephedra is a second and a completely different approach to federation. It addresses a situation when you want to connect to data sources which are not knowledge graphs. This happens also in many situations. And for example, REST APIs or SQL databases can provide you with a lot of cool data that you would like to quickly have as part of your solution. And how it works, it is that the system creates a virtual knowledge graph from the data returned by these API calls, so that a Sparkle programmer can use this together with the existing knowledge graph to build applications. These two technical possibilities are established, and I think if this is something that created your interest, feel free also to reach out to me or to my company for more details. And with that, I hand over back to the team and the audience. Thank you for your attention.
Thank you, Peter. We have a very healthy influx of questions. And there are a few questions that, in somewhat different language, speak about the same topic. And maybe in the interest of time, I will try to summarize. They are asking, there are multiplicities of ontologies referring to the same topic. There are also master ontologies that go over individual subject matter ontologies. Maxim, how do you make sure that the different data domains that you operate in remain interoperable and the data interpreted according to the specific ontologies basically match? And as I mentioned, this is my retelling of many questions that effectively ask about the same thing: interoperability in a world where multiple ontologies exist.
Tim, you're muted.
Yeah, I got the question, I think. So, yeah, I don't think there is a actually easy solution today, at least not widespread, right? There are different ways how people manage ontologies, and I think this is the area where things need to be improved. So I'm thinking that, I mean, first of all, in general, if we want to make this kind of solution scalable, it needs to be really well explained, and we need to stop doing different kinds of approaches to the ontology management, right? Secondly, there should be methodology which would allow us to build like a modular ontologies from the beginning, not a huge one giant ontology which then duplicates something else people built some time ago or built in parallel in a different organization, right? So this is a really a challenge and an opportunity to improve things. And yeah, one of the I really focus areas where I mean, I think vendors need to help us here. We need to work on that internally in the companies to educate people and adopt methodologies, right? And I mean, we have a software development process. It's not always perfect everywhere. We have different methodologies as well, and it should be similar for ontology development. What I see, one direction where I see we're going sometimes is that we're again building ontologies for specific use cases, right? Basically, we're creating duplicates and again manual work, right? But I think it's caused by the fact that there are not so many ontologies you can actually reuse easily. So everything needs to be adapted. And another thing is that this methodology I'm talking about, which need to be in place and used wider, it needs to be adapted from the beginning to this our new AI era, right? So when we're building ontology, we need to know that it's going to be understood by the LLMs, right? So yeah, it's cool that you can build an ontology, that it can describe your data, and yeah, sometimes it's simple, sometimes complicated, but it should be understandable by LLMs, right?
When you have a large language model that has to operate on an ontology, how do you feed that ontology into the large language model?
Mm-hmm.
The reason for that question is that in my personal experiments, the ability of LLMs to understand the O language has been poor.
Mm-hmm.
May I would like to comment on this. I think it's our experience, and we're doing this a lot to upload ontologies to large language models to inform an agent about the data, basically. Mm-hmm. And the experience is that if you have an ontology that is hard to understand for humans, the same happens with a large language model. That means what you need to have is really very explicit, good descriptions, rich semantic in your ontology. It should also be not too big, so that also a large language model has the capacity to capture the complexity that it needs to resolve in order to, for example, generate out of this description a Sparkle query. So that's something that reflects our experience. But now that I'm speaking, maybe I would like also to add a comment to the earlier discussion. Our platform provides modeling capabilities, and our customers are mainly very large companies who are into very big ontologies built by many people. So a clear requirement from all these customers is to have a governance process where you have the ability, some team members, they can propose new parts of the ontologies, others have the authority to accept it. You have a versioning process that develops this over time. and you need to have the ability to import accepted and ready-made ontologies. A combination out of that, together with a process that people accept and have been taught to, this is more like the organizational aspect, this is necessary for large-scale ontology development. And also, I think where we are now is that we need to help people understand, those people who create ontologies, understand what they need to do so that their ontology at the end of the day can be understood by a large language model. Yeah, again, good descriptions, good semantic input. That's what needed.
Which takes us actually to the next set of questions with a common theme. And that common theme is interoperability between ontologies and common concepts. To make use of one specific question, which was asked, I guess, a little bit tongue-in-cheek. Is there consensus amongst the pharma companies on which ontologies to use for common concepts? So, do you have any ideas about how to promote interoperability between ontologies? Do we need general pharma ontology? Can Pistoia Alliance projects contribute to establishment and promotion of quality ontologies that can be then used across the industry and maybe across multiple industries?
Yeah. So I cannot answer this question directly, but my opinion is that I mean, I'm not, I'm not expert in the domains, right? So I cannot comment. Yeah, I know there are a lot of initiatives in describing, pharma concepts like IDMP ontology, which we actually use quite a lot, and others. My opinion is that we need more infrastructure for sharing these ontologies and better infrastructure maybe to simplify onboarding of these ontologies into internal data ecosystems. So this is what I see as a challenge today. So we have nice solutions like the one Peter described and which Metafacts provides. But the way to easily distribute these ontologies developed by communities like Pistoia Alliance, for example, and others, I think that's what is missing, because I see that people need to, ontology is created. Now, how do we bring it internally? Because we have our own tools internally, unfortunately, although the standard is the same, but you still need to tweak metadata a bit. Like, the labels are easy, but for example, versioning, how the versioning of the ontology and provenance. Yeah, okay, and we also have ontology for the provenance, but to merge all these things together and have a good infrastructure, that's what for distribution is what I think is missing.
Mm-hmm.
I think we can see some initiatives, and we work across several industries. And IDMP was mentioned already for pharma, but there are similar initiatives for example, engineering. We have Cyphos. If you put the two side by side, you would say there's no overlap, nearly no overlap. So that means also maybe not only industry specific, but also use case specific. Is this discussion also inside of a pharma company? We have seen it. Supply chain, R&D, they are in really two different worlds. They have different use cases and probably would require also very specific ontologies to support their work. So I think it's a good and unsolved question how to connect everything into one meta thing. But the first step, I would say a pragmatic step, is really to look into specific use cases and what are the ontologies that we need there. This is where we can start with, and there are, I think, good initiatives inside of the Pistoia Alliance already to make progress on that.
And I see a lot of comments coming into the question and answer system mentioning the Pharma general ontology of the Pistoia Alliance and various other public and private projects dedicated to promotion of ontologies. There is one from Open Facts Foundation platform, Onto Portal Alliance, is mentioned, and the Allotrope Foundation is also mentioned. There is another group of questions that perhaps we can take in the last few minutes. In the organizational angle, there is always resistance to change. How do you deal with resistance to change on organizational level and also on technology level? For example, as an example of the technology resistance to change, one attendee is commenting that a lot of people learn SQL. Now they're confronted with the graph databases, SQL doesn't work. So how do you coach them to be more effective? Maybe our speakers can comment on that as well.
Yeah, that's quite frustrating sometimes, right? But I think we need to accept that this situation, and I don't think that we should think about replacing one with another, because everything is useful at the end in their own areas. And what I also found is that it's not really productive to talk about let's replace something with something else. It's better, the discussion is more productive when we're talking about, hey, we can improve this particular process by introducing a different solution. Yes, it's based on the knowledge graph and RDF and so on, but doesn't matter. As soon as it improves, can create business process and generates value, and it's really visible and easy to explain. If you don't have it right, it's quite, it's not possible to have a productive discussion in the organizations, because there are quite a lot of technological like inertia, I would say, which comes from human nature, I assume. So that's would be my view. Focus on business value and trying to improve something with this technology, and not trying to go everywhere and start talking about it. Yeah, the knowledge graphs are cool, ontologies are cool.
And we are unfortunately almost out of time at this point. I would like to use the last few seconds to thank Peter and Maxim, our speakers today, for talking and taking a lot of questions. We have many more questions that we could possibly answer in the live webinar. There are 24 open questions in my incoming queue right now. With apologies to everyone who asked the question, but we were not able to take it live. We will group your questions and we'll see if we can answer them by email sometime later after the event. Once again, profound thanks to Peter and Maxim for the very engaging conversation. And thank you for all attendees for coming and being part of this event.
Thank you very much.
Thank you.